Well, good morning or good afternoon. This is Mr. Kinney. I'm going to go over your homework, which is the metrics and measurement and the dimensional analysis practice problems. We've got 12 problems here. For period 1 and 7, this is going to be due on Thursday, not Tuesday. You've got a little more time. I changed this data table up here for period 1 and 7. You've got the old one that doesn't work. I'll provide that with you on through Remind. So when you work these, just like we've done in class, you've got a whole bunch of givens here that you'll start, and here's the stick and fences method. The dimensional analysis is the fancy name for that. Starting with our givens and then putting our fractions in over here that we multiply by. Some of the fractions, or the conversion factors, are going to be shown right in these sample problems. Other ones, they've got them in here. For the new sheet that I'm going to give you, I've got a few of them down here, and then we have them up there. I'm going to zoom in now. Okay, so for our first problem, okay, coming up here we've got our base units, 1 gram, 1 liter, 1 meter. Deci, centi, milli, and micrograms, and that shows you that for example, 1 gram would be 10 decigrams, 100 centigrams, 100 milligrams, 1 million micrograms. Over here the other way, if you have 1 gram, it's going to be 0.1 decagram, 0.01 hectogram, 0.001 kilograms, and 0.00001 megagrams. So that's how we work this. And this will be what we'll use for our conversion charts. So for the very first problem down here, question number 1, it's asking us to convert 35 milliliters, ml, and it wants us to go into decaliters, dl. So I'm going to come up to here now. So look for the D. Okay, so decaliters, we're using the liters here. So this is our given, and I'm just going to go ahead and do what we do in class. 35 milliliter, we'll put that over 1. That's our given from the problem. And we're going to convert it to decaliters. So I'm going to put this over here. And our conversion factors that we're going to use, we're going to go from deciliters to from milliliters to decaliters. So what I'm going to put over here for the conversion factor, I'm going to say 1,000 milliliters. So I'm just put that 1,000 milliliters, okay, is going to be the same as 10 decimeters per 10 decimeters. So I'm just looking over here. There's 1,000 of the millis for every 10 of the decis, and we got that set up there. And I've been practicing with you that you could also use the reciprocal. 10 decimeters is 1,000 millimeters. Excuse me, milliliters. We're using, we're using liters. This should be L, and that should be liters. Sorry about that. So we want to get rid of the milliliters, so we need to use this fraction, because by setting that one up, you'll have your 1,000 milliliters for every 10 deciliters. So with your calculators at this point, you multiply those two, divide by that. If you want to make it a little easier, you can cancel out the zeros. Oh yeah, we can cancel out the milliliters there. That tells us we set it up right. It becomes 35 divided by 10. I'll do one more. I'm not going to do the actual answer there. Let's see here. I'll come over here and we'll do number 6. Let's see, 2, 3, 4, 5, 6. I'm just going to set up number 6 right here. Number 6, the given, make sure I'm on the screen here for you. The given in number 6 is 4,500 mgrams. And if you're not sure m, you look up here. Oh, that'll be milligrams. And we want to find out how many regular grams that is. So we want to find regular grams. So I'm going to set up this. Oh, sorry, I should have put there's the 1 for putting our given over 1. And now we got to convert between milligrams and grams. So looking on our chart here, 1 gram would be, there's 1,000 milligrams. So I'm going to put over here 1 gram per 1,000 milligrams. So I'm just taking what the chart showed us. 1 gram would be 1,000 milligrams. And actually, it turns out this is the fraction we need to put in here because we want to get rid of milligrams. Let's get that over. Zoom it in a bit. So I'm going to put this fraction there, 1 gram for every 1,000 milligrams. That cancels. That cancels. We know we set it up right. You probably don't even need a calculator to do that. Now some of these you're going to have to do on this side. There's going to be some bigger conversions. You're going to have to use several. And we got some weird stuff. Like here, number 6 on this side over here. 3 moles. Okay, that's a big number in chemistry. But what's a mole? Well, it tells you. 1 mole is 6.02 times 10 to the 23. I'll write that a little bigger because I know it was tough to see on there. Times 10 and to the 23rd molecules. So when you go to enter those in on your calculators, I'll show you how to do that. We'll practice here. But to enter an exponent, a big number like that, I'm going to turn this on, hit clear, zoom out a bit. Your calculators may have, like this one here has an EE button. That EE means times 10 to the this. So that would be EE on the class set of calculators that we have. A lot of you may have this calculator here. A lot of them, you'll have it set up like this. They'll have times 10 to the x. That's pretty cool. You can just put in the number, hit that. So there's some different ones. I'm going to use the class set one because most of us have that. So to enter in this really big number in scientific notation, we enter in 6.02. Do not hit times. 6.02. Then you're going to push EE, the engineering exponent. Or if you had the calculator, it said times 10 to the x, you would do that. Up here, little zeros appear. So now we're going to enter in our exponents, 23. And now you can multiply or divide that as you need. We'll practice that in class. Bye.